In 1943, across the vast plains of the Eastern Front, a terrifying discovery forever shifted the balance of power between armor and infantry. Soviet soldiers, accustomed to the supremacy of their formidable T-34s, began to witness something impossible. Their invincible tanks being obliterated by German foot soldiers, armed with metal tubes that seemed too primitive to pose a real threat. What these tank crews didn't know was that they were facing a technological revolution born of German desperation, the Raketenpanzerbüchse 54, known as the Panzerschreck. This 80-3mm weapon, weighing just 21 pounds, possessed a devastating capability that defied all military logic. A single 7.3-pound rocket could penetrate up to 8.2 inches of steel armor, transforming the proud Soviet tanks into deadly furnaces. The lethal precision of this weapon lay not only in its technology, but in the psychological transformation it wrought on both sides of the conflict, completely redefining armored warfare tactics in the bloodiest theater of World War II. The development of the Panzerschreck was born from a bitter irony of war. The Germans, masters of military engineering, were forced to copy a captured American weapon. In 1942, during the fighting in North Africa, German soldiers recovered damaged American bazookas and sent them for analysis in Germany. What they discovered shocked them deeply. The Americans had developed an elegant and effective solution to the anti-tank problem that plagued German infantry. However, German engineers were not content with simply copying. They perfected the concept with their characteristic obsession for precision. They increased the caliber from 60mm to 88mm, developed a more powerful hollow-charge warhead, and created a sighting system that allowed for accurate engagements up to 165 yards. The result was a weapon that dramatically surpassed its American predecessor, capable of penetrating armor that even conventional anti-tank cannons couldn't pierce. This transformation of a war prize into a superior weapon exemplified Germany's capacity for innovation under pressure, but it also revealed a strategic vulnerability: their growing reliance on desperate defensive solutions. The Panzerschreck's first real combat experience occurred at the hands of Obergefreiter Klaus Richter of the 12th Panzergrenadier Division during the Battle of Kursk in July 1943. Richter, a 23-year-old veteran who had lost two brothers on the Eastern Front, received one of the first production units with visible skepticism. It looked like a drainage pipe with a sight, he would later write in his diary. How could this stop a T-34? His first opportunity for an answer came when a formation of 5 T-34-76 tanks advanced through a wheat field near Prokhorovka. Positioned just 130 yards away, Richter loaded the 7.3-pound rocket into the rear of the tube, adjusted the rudimentary sight, and fired. What happened next changed his perspective forever. The rocket struck the lead T-34 directly on the side of the turret, piercing the 1.8-inch armor as if it were paper. The internal explosion instantly killed the entire 5-man crew, while orange flames erupted from all the tank's openings. At that moment, Richter recorded, I understood that we had something in our hands that would change everything. The Panzerschreck's technical superiority over conventional anti-tank weapons lay in its revolutionary hollow-charge warhead, a technology that transformed the basic principles of physics into concentrated destructive power. Unlike conventional projectiles that relied on kinetic energy to penetrate armor, the Panzerschreck's hollow charge utilized the Monroe effect, a phenomenon discovered decades earlier but only recently applied in weaponry. When the rocket impacted the target, a conical explosive charge of 1.45 pounds of composition B detonated, creating a jet of molten metal traveling at speeds exceeding 26,246 feet per second. This superheated jet, with a temperature of approximately 1,132 degrees Fahrenheit, literally melted and pierced the armor, creating a small but devastating entry hole. What made this technology truly terrifying was its independence from impact velocity. Unlike conventional projectiles, the effectiveness of the hollow charge did not diminish with distance, maintaining its full destructive power even in long-range engagements. For Soviet tank crews, accustomed to the reliable protection of their sloped armor, this new reality represented a technological nightmare where steel thickness became irrelevant in the face of German scientific precision. The psychological impact of the Panzerschreck on Soviet tank crews was as devastating as its physical effect. Lieutenant Dmitry Volkov, commander of a T-34-85 from the 5th Guards Tank Army, described in an intercepted German letter the radical transformation in his unit's mindset after the first encounters with the new German weapon. Before, we were the hunters, Volkov wrote. Our T-34s were invincible, and German infantry fled when they saw us approach. Now, every German soldier with a tube on his back can kill us. We can no longer sleep knowing that our armor does not protect us. This psychological shift manifested in increasingly cautious tactics, with Soviet tank formations avoiding areas where German infantry might be entrenched. The fear of the Panzerschreck forced Soviet commanders to completely modify their armored doctrine, increasing engagement distances and demanding massive artillery support before any advance. Paradoxically, a German defensive weapon had managed to transform the Soviet offensive force into a hesitant and predictable formation, demonstrating how pinpoint technological superiority could influence strategies on a much larger scale. The Panzerschreck's operational experience revealed both its extraordinary capabilities and its practical limitations that defined life and death on the battlefield. Unteroffizier Hans Mueller, a veteran of 156 anti-tank engagements with the Panzerschreck, developed an intimate understanding of this lethal weapon's technical and human aspects. The 21-pound weight doesn't seem like much until you carry the weapon for 9 miles through mud and snow, Mueller recalled in his post-war memoirs. But when you see a T-34 at 110 yards, that weight becomes insignificant. Operation required precise coordination between 2 men, the gunner, who positioned the 65-inch tube on his right shoulder, and the loader, responsible for inserting the rocket through the rear opening and connecting the electrical firing circuit. The loading process, which initially took 45 seconds for inexperienced teams, could be reduced to 12 seconds by veteran operators like Mueller. The optical sight, calibrated for distances of 55 to 165 yards, allowed for surprising accuracy, but required the gunner to keep the target centered in the reticle for at least 3 seconds after firing to ensure the rocket maintained its stable trajectory. This need for prolonged exposure transformed each shot into an act of calculated courage, where technical precision met human determination. The most dangerous aspect of the Panzerschreck's operation came not from the enemy, but from the weapon itself. The rocket's propulsion system created a 33-foot deadly zone behind the gunner, where toxic, superheated gases were expelled at temperatures of 1,292 degrees Fahrenheit. Obergefreiter Franz Weber learned this lesson traumatically during the defense of Berlin in 1945, when he fired his Panzerschreck inside an unventilated building. "The gases burned my lungs instantly," Weber reported years later. "My loader passed out, and I was blind for 2 hours, but the T-34 was destroyed." This limitation forced the development of specific tactics, firing positions always in open areas, with planned escape routes, and the mandatory use of the protective shield, a 3.3-pound steel plate that protected the gunner's face from gases and debris. The characteristic white smoke produced by the firing, visible from over 550 yards, also immediately revealed the team's position, requiring a rapid change of position after each shot. These technical limitations created an operational paradox, a devastatingly effective weapon that demanded exceptional courage and technical discipline to be employed safely, transforming each Panzerschreck team into highly trained specialists whose survival depended as much on their accuracy as on their ability to quickly disappear after each lethal engagement. The Panzerschreck's ballistic superiority over conventional anti-tank weapons of the era represented a technological leap that completely redefined the parameters of armored combat. While German 75-meter PaK-40 anti-tank cannons required fixed positions, 6-man crews and 15-pound ammunition for each projectile, the Panzerschreck offered unparalleled tactical mobility with its crew of just 2 operators. The rocket's initial velocity of 360 feet per second, although significantly lower than the PaK-40's 3,150 feet per second, was compensated by its stable trajectory and penetration capability, independent of impact velocity. This unique characteristic allowed for effective engagements even at oblique angles, where conventional projectiles ricocheted ineffectively. The effective range of 165 yards, initially considered a limitation, proved ideal for urban and defensive combat, where German infantry could use natural cover for stealthy approaches. Ballistic tests conducted at Kummersdorf demonstrated that the Panzerschreck could consistently penetrate 8.2 inches of homogeneous armor at 90 degrees, significantly surpassing the PaK-40's 7.3-inch penetration capability under the same conditions. This technical superiority transformed every infantry soldier equipped with a Panzerschreck into an anti-tank threat equivalent to an artillery piece, exponentially multiplying German defensive capabilities. The production and distribution of the Panzerschreck revealed both German industrial efficiency and the growing pressures of total war. The Hasag factory in Leipzig, quickly converted from conventional ammunition production, managed to produce 289 Naue 151 launchers and 2,218 400 rockets between 1943 and 1945, numbers that demonstrated the strategic priority assigned to this weapon. Each launcher cost 70 Reichsmarks to produce, compared to 2,400 Reichsmarks for a complete POC 40 cannon, representing a revolutionary cost efficiency. The manufacturing process, optimized by engineer Dr. Heinrich Langweiler, utilized lower-quality steel and simplified welding techniques that allowed for mass production without compromising effectiveness. The rockets, manufactured in underground facilities to avoid Allied bombing, incorporated extremely sensitive impact fuses that ensured detonation even against sloped armor. Distribution followed a rigid priority system, first to Panzergrenadier units on the Eastern Front, then to infantry divisions in defensive positions, and finally to Volkssturm units in the defense of the Reich. This hierarchy reflected German recognition that the Panzerschreck had become essential to compensate for the growing numerical inferiority of their tanks, transforming infantry into an anti-tank force capable of confronting massive Soviet armored formations. The Panzerschreck's first major test in mass combat occurred during Operation Bagration in June 1944, when the German Army Group Center faced the largest Soviet armored offensive to date. The 4th Panzergrenadier Division, commanded by General Friedrich Sixt von Arnim, had received 180 Panzerschreck launchers just 2 weeks before the start of the Soviet offensive. What followed was a devastating demonstration of this new weapon's effectiveness in real combat conditions. In just 3 days of intense fighting near Vitebsk, the division's Panzerschreck teams destroyed 127 Soviet tanks, including 34 of the feared T-34 Sar-85s and 12 heavy IS-2 tanks. Hauptmann Ernst Barkmann, commander of the 2nd Battalion, recorded in his official report the psychological effect on Soviet tank crews was immediate and dramatic. Formations that previously advanced with confidence began to hesitate, allowing our defensive positions to maintain coherence even under extreme pressure. The Panzerschreck's lethal precision forced Soviet commanders to modify their tactics, increasing engagement distances and demanding much more intense artillery preparation before each advance, effectively slowing the pace of the offensive and allowing German forces to execute organized retreats. The tactical evolution of Panzerschreck employment demonstrated the adaptability of German military doctrine under extreme pressure. Initially distributed as a support weapon for infantry squads, the Panzerschreck quickly evolved to form the backbone of specialized anti-tank units. Oberst Hans-Ulrich Rudel, though famous as a Stuka pilot, developed innovative ground tactics for the coordinated employment of Panzerschreck teams during the defense of East Prussia. His anti-tank cells consisted of 3 Panzerschreck teams positioned in a triangular formation, with 55-yard distances between each position, allowing for devastating crossfire against Soviet armored formations. This configuration maximized hit chances while minimizing the risk of premature detection, as only one team would fire initially, keeping the other 2 in reserve for subsequent engagements. Communication between teams was maintained through simple visual signals, eliminating the need for radio equipment that could be intercepted. These tactics proved so effective that they were quickly adopted across the Eastern Front, transforming the Panzerschreck from an individual weapon into an integrated weapon system capable of halting numerically superior armored advances. The Soviet response to the Panzerschreck revealed both the Red Army's tactical flexibility and the profound impact this German weapon had on Soviet armored doctrine. General Vasily Zhukov, commander of the 8th Guards Army, was one of the first to recognize the threat posed by the Panzerschreck and to develop specific countermeasures. In a classified report sent to Stavka in August 1944, Zhukov wrote, "This new German weapon has transformed every enemy soldier into a potential anti-tank threat. Our traditional armored advance tactics have become obsolete overnight." The Soviet response was multifaceted and demonstrated the adaptability that characterized the Red Army. First, they dramatically increased the use of preparatory artillery, with saturation barrages lasting up to 2 hours before any armored advance, aiming to eliminate German infantry positions. Second, they developed leapfrog tactics, where tanks advanced in small groups of 3 to 5 vehicles, with 220-yard intervals between each group, minimizing losses if a Panzerschreck position was activated. Third, they intensified the use of supporting infantry, with Soviet soldiers advancing 110 yards ahead of the tanks to identify and neutralize German anti-tank teams. The evolution of Soviet armor in response to the Panzerschreck demonstrated the technological arms race that characterized the final years of the war. The development of the T-34-85, with its redesigned turret and frontal armor increased to 3.5 inches, was partly motivated by the need to resist Panzerschreck attacks. However, Soviet engineers quickly realized that simply increasing armor thickness was ineffective against hollow charges. The solution came in the form of spaced armor and reactive armor plates, revolutionary concepts that would be perfected decades later. The T-44, introduced in 1944, incorporated detached side plates that prematurely detonated Panzerschreck rockets, significantly reducing their effectiveness. Simultaneously, the Soviets developed the RPG-2, a direct copy of the captured Panzerschreck, demonstrating recognition of the German design's superiority. This involuntary technological transfer represented a historical irony. The weapon that the Germans had developed by copying the American bazooka was now copied by the Soviets, creating a cycle of innovation and counter-innovation that would define anti-tank weapon development for decades. The Panzerschreck's impact transcended its immediate effectiveness, forcing a conceptual revolution in armored warfare that would influence tank design and anti-tank tactics to this day. The Panzerschreck's supply logistics revealed the growing challenges faced by the German war machine in the final years of the conflict. Each rocket weighed 7.3 pounds and measured 25.6 inches in length, creating unique transportation and storage challenges. Oberquartiermeister Friedrich Paulus, not to be confused with the general from Stalingrad, developed a distribution system that prioritized efficiency over traditional safety. Rockets were transported in wooden crates containing 6 units each, with a total weight of 55 pounds per crate, allowing a soldier to carry enough ammunition for prolonged engagements. The sensitivity of the fuses required special care during transport. Each rocket was individually packed in straw, and transport vehicles could not exceed 18 miles per hour to avoid accidental detonations. This speed limitation created significant logistical vulnerabilities, especially during rapid retreats when supply convoys became easy targets for Allied aviation. The field resupply system, developed by Hauptmann Klaus Weber, utilized advanced depots located no more than 1-2 miles from the front lines, allowing for rapid replenishment during intense combat. Each depot contained 200 rockets and was operated by a 3-man team trained in explosives handling, demonstrating the strategic importance attributed to maintaining a continuous supply of this revolutionary weapon. The training of Panzerschreck operators evolved from a basic 2-week program to an intensive specialization course that produced some of the most effective soldiers in the German army. The training center in Doberitz, commanded by Major Heinrich Müller, developed a curriculum that combined ballistic theory, firing practice, and combat survival tactics. Recruits first learned the physical principles of the hollow charge, understanding how the conical detonation created the jet of molten metal capable of piercing armor. This technical education was not merely academic. Soldiers who understood the weapon's operating principles demonstrated greater accuracy and confidence in combat. Practical training included 50 live fire shots against armored targets, allowing operators to develop intuition for engagement distances and angles. The most crucial aspect of the training was combat stress simulation. Exercises conducted under simulated artillery fire, with deafening noise and dense smoke, prepared soldiers to maintain accuracy under extreme pressure. Graduates of this program, identifiable by a special golden rocket insignia, achieved hit rates of 89% in real combat, compared to 34% for operators trained only in the field. This difference in effectiveness transformed well-trained teams into force multipliers capable of halting entire armored formations with minimal resources. The Panzerschreck's strategic impact on the Eastern Front transcended its tactical function, influencing operational decisions at higher command levels. General Heinz Guderian, in his post-war memoirs, credited the Panzerschreck with Germany's ability to maintain organized resistance during 1944, when Soviet numerical superiority had become overwhelming. Without the Panzerschreck, Guderian wrote, our infantry divisions would have simply been swept away by Soviet armored formations. This weapon gave us the ability to transform every defensive position into an anti-tank fortress. Statistical analyses compiled by the OKH, Oberkommando des Heere, demonstrated that divisions equipped with Panzerschreck maintained defensive cohesion 340% longer than units dependent solely on conventional anti-tank cannons. This prolonged resistance capability allowed for organized retreats and the maintenance of coherent defensive lines, crucial factors in preventing the total collapse of the Eastern Front. The Panzerschreck also influenced the allocation of German resources. Tank production was reduced in favor of greater production of portable anti-tank weapons, reflecting a strategic shift from an offensive doctrine to an optimized defensive posture. This doctrinal transformation, though born of necessity, demonstrated how a specific technological innovation could completely reshape a nation's military strategy. The psychological influence of the Panzerschreck extended beyond the battlefield, affecting the morale and confidence of both German and Soviet forces. Intercepted Allied intelligence reports revealed that the mere presence of Panzerschreck teams in an area forced Soviet commanders to modify entire operational plans. Colonel Ivan Petrov of the 3rd Guards Tank Army wrote in a report to Stavka, "The threat of the Panzerschreck has transformed every advance into a complex operation, requiring massive artillery preparation and air support. Our tank crews, once confident and aggressive, now hesitate before every German position." This tactical hesitation translated into significant operational advantages for the Germans, who could use the additional time to fortify positions, reposition forces, and coordinate counterattacks. Paradoxically, the Panzerschreck's success also created psychological pressures on the German operators themselves. The responsibility of halting entire armored advances with an individual weapon created extreme stress, documented in medical reports showing a high incidence of combat fatigue among Panzerschreck operators. However, the prestige associated with mastering this lethal weapon also boosted unit morale, creating an informal elite of tank hunters whose exploits became legendary among German troops. A comparative technical analysis between the Panzerschreck and its Allied equivalents revealed German superiority in portable anti-tank weapon design during this critical period of the war. While the American M9A1 bazooka used a 60mm rocket with a penetration capability of only 3 inches of armor, the German Panzerschreck, with its 88mm projectile, could penetrate 8.2 inches of homogeneous steel. This 276% difference in penetration capability was not merely quantitative, it represented the difference between a weapon effective against light armor and one capable of destroying any tank in service. The British Piat, though innovative in its spring mechanism, suffered from a limited range of only 110 yards and questionable accuracy, making it unsuitable for engagements beyond very short distances. German superiority also extended to engineering aspects. The Panzerschreck's electrical ignition system was more reliable than the bazooka's percussion system, especially in adverse weather conditions. The German warhead used a refined copper alloy for the hollow charge cone, producing a more efficient penetration jet than Allied designs that employed inferior materials. Ballistic tests conducted at Aberdeen Proving Ground after the war confirmed that the Panzerschreck maintained superior effectiveness even when fired at oblique angles of up to 60 degrees, a capability that no equivalent Allied weapon possessed. The Panzerschreck's technological legacy profoundly influenced the development of anti-tank weaponry in the post-war era, establishing design principles that remain relevant today. The Panzerschreck's combination of portability, firepower, and operational simplicity became the standard for all subsequent anti-tank weapons. The Soviet RPG-7, developed in the 1960s and still widely used, incorporates fundamental concepts derived directly from the German design: large diameter caliber, optimized hollow charge warhead, and rocket propulsion system. The German influence is even more evident in the development of the American M72 Law and the Swedish AT-4, both utilizing ballistic and structural design principles pioneered by the Panzerschreck. The tactical employment doctrine developed for the Panzerschreck, 2-man teams, ambush positions, fire, and rapid movement, became the basis for modern anti-tank training in armies around the world. Even more advanced systems like the American Javelin and the Israeli Spike, despite incorporating sophisticated guidance technology, retain the fundamental operational concepts established by the German Panzerschreck pioneers. This technological continuity demonstrates how an innovation born of wartime desperation transformed into a lasting legacy that continues to influence weapon design and military tactics more than 80 years after its creation. The final and irreversible transformation caused by the Panzerschreck in armored warfare represented much more than a simple technological innovation. It was a conceptual revolution that permanently redefined the balance between attack and defense on the modern battlefield. When the last rockets were fired in May 1945, during the desperate defense of Berlin, they ended not only a chapter of World War II, but an entire era of unchallenged armored supremacy. The Panzerschreck had demonstrated that technology, applied with scientific precision and human determination, could equalize seemingly insurmountable numerical disparities. Its ability to transform ordinary infantry soldiers into lethal tank hunters set a precedent that would echo through decades of subsequent conflicts. From the jungles of Vietnam to the deserts of the Middle East, the fundamental lesson remains unchanged. In war, superiority lies not just in numbers or size, but in the ability to innovate, adapt, and apply technology with devastating precision. The Panzerschreck's legacy transcends its immediate tactical effectiveness. It represents definitive proof that, in the right hands, a single technological innovation can alter the course of history, transforming the impossible into the inevitable, and forever redefining the parameters of what power means on the modern battlefield.